Hello boys and girls, Mr. Giomini. Want to come to you with a little bit of test preparation as we get ready for our Chapter 2 post-test coming up here. Let's take a look at a couple here. It says evaluate. Evaluate is a fancy word for solve. So whenever I see evaluate, I'm going to solve. Now I see we have multiplication, subtraction. Reminds me of something called PEMDAS. Remember PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Remember here we have whatever comes first from left to right, and then here we have whatever comes first from left to right. Let's take a look and tackle that first one. 4 times 6 minus 6. First thing I notice is that I have multiplication and subtraction. Looking at my PEMDAS here, no parentheses, no exponents. Multiplication, there's multiplication, no division, so I don't have to worry about going left to right. And then I go addition and subtraction. What I'm going to do first, I'm going to multiply 4 times 6. 4 times 6 is 24. I will bring down what I did not use. I did not use the minus sign. I did not use a 6. And then we have 24 minus 6 gives me 18. This would should give me 18. Again, a great strategy, boys and girls. I'm going to solve all three of these. You should maybe try solving all three, pause the video, and then come back and listen to my explanation. That way you can check your work against mine. Next one, we have 32 plus 4 to the third power. Here's where sometimes we get off. Divided by 8. Again, going to my PEMDAS over here, no parentheses, but I do have exponents. 4 to the third. Now remember, 4 to the third, it's just a fancy way of condensing 4. I'm going to write it down here. 4 times 4 times 4. It just shortens that. 4 times 4 is 16. 16 times 4 gives me 64. I bring the addition sign down. I did not use that. I'll bring the 64 down. I'll bring the divide by 8. I am left with two operations. I am left with addition and division. Now I go back to my PEMDAS. I'm done with parentheses. No exponents done. I have multiplication and division. Let's see, whatever comes first from left to right. And it's division because there's no multiplication. So the 32 will stay. I did not use that addition sign. 64 divided by 8 is 8. I now only have addition left, and I know what is 32 plus 8. That should give you 40. Again, great strategy, boys and girls, to help with preparation. Write these three down. Pause the video, try to solve all three, and then come back and check against the video. You don't have to listen to the video straight through. My voice is annoying, I know. 5 times 9, in parentheses, 9 minus 6. I look at my PEMDAS. Parentheses, yes, I do finally have some parentheses. 9 minus 6 is 3. Now I bring down what I did not use. I did not use the 5. Remember, we're using a dot for multiplication, and it's not a decimal point. It's where a multiplication sign would typically be the X, but now we use the dot to signify or to represent multiplication because we get into variables and are using the X. 5 times 3 is 15. I have an answer of 15. All right, let's take a look at another one here. Some more examples. I'm not going to do all of these. I'll do this. I'll do this one because I find that most taxing, and this one. Now again, pause the video. Attempt to do the prime factorization of 28 and of 200. Let's take a look at 28. Now remember, prime factorization, think of factor trees. I always think, I know you guys like to do divide by 2. I'm a little bit better with my multiplication facts, not because I'm smart, just because I'm old. 28, that's 7 times 4. I automatically know that 7 is prime. I will circle that. That means leave it alone. 4 can be factored out as 2 times 2. They are both prime. I now know as a string of prime numbers, it's 2 times 2 times 7. If I want to write it in exponential notation, it is 2 to the second power times 7. These two statements mean the exact same thing. One's stringed out in prime factorization string. This is exponential notation. Let's go to 200 now. 200. I know 50 goes into 200, and I believe it goes in there 4 times. 50 plus 50 is 100, plus another 50 is 150, plus another 50 is 200, so 50 times 4. Let's break up 4 into 2 times 2. There's my prime numbers. I will circle them. 50, I think, is 25 times 2. 2 is prime. I'll circle it. 25 is 5 times 5. Those are both prime. As a string of prime numbers, it is 2 times 2 times 2. And I can cross these out as I write them, so I don't reuse them. Times 5 times 5. If I want to write that in exponential notation, it is 2, and there's 3 2s. So it's 2 to the third times, and there are 2 5s, 5 to the second power, or 5 squared. Okay, now we're doing greatest common factor. This one we struggle with, in part because we struggle with our prime numbers. And I do it a little differently than your teacher did last year. We have 14, we have 28, and we have 70. Now, look at this. I already did have 28 up here. It's 2 times 2 times 7. 2 times 2 is 4. 4 times 7 is 28. 14 is just 2 times 7. Now 70 is a string of prime numbers. Let me see. I could do a factor tree for this as well. It's 7 times 10. 7 is prime. 10 is 2 times 5. Those are both prime. So a prime factor string for 70 is 2 times 5 times 7. Now remember, for GCF, greatest common factor, the factor must be common for all of them. I have a 2, a 2, a 2. I will pull that 1, 2 out. Okay, I have a 7, and a 7. All three have a 7. I will pull that 7 out. Now, this has a 2, but not all of them have 2. Cross it out. This has a 5, but not all of them have a 5. Cross it out. 2 times 7 is 14. That means the GCF, the greatest common factor for these, is 14. Now let's take a look and see how least common multiple is slightly different. Again, I encourage you to pause the video, try this problem yourself, see if your answer comes up with mine. You can check your work. What a great way to have notes and check your work at the same time. We have, let me change colors here, we have 6, 12, and 15. Now let's do the prime factorization of 6. Not too bad. It is 2 times 3. Now I know 12 is 3 times 4. But 4 can be broken up to 2 times 2. And then 3 is already prime, so 3. 15 is 3 times 5. Now the difference between GCF and LCM. LCM, at least 2 have to have in common. If all of them have in common, great. But if only 2 have in common, it still counts as a pairing. I see that we have a 2 here and a 2 here. Remember, we don't have to have a 2 all the way across for LCM. So that puts 1, 2 down here. I have a 3 here. All 3 have a 3. That means it's just 1, 3 down here. Now is when I have the junk. Nothing else has a 2, nothing else has a 5. So we bring the garbage down to the curb. We add that 2 down here, and we add that 5 down here. Now I multiply. 3 times 2 is 6. 2 times 5 is 10. 6 times 10 is 60. So there, LCM for 6, 12, and 15 is 60. Let's take a look at more problems. I'm going to do number 21 and 22, and then I'll do 23, 24, and 25. Great opportunity right now to pause the video, attempt to do number 21 and 22. If you want to then restart it, see if you had those right, and then pause again to try to convert these or translate these word phrases to algebraic expression. 21 is a great one because I see many kids missing them. So we have 3x squared minus 2 times x, 4, because we can't solve this unless you tell me what x equals, and it tells me x is equal to 6. Now it says evaluate, fancy word for solve. Solve each algebraic expression for the given variable values. They're going to give us the values. Now let's substitute the 6 in wherever I see an x. So this becomes 3. Now it doesn't become 36, it's 3 times 6, and the 6 is squared. Minus, it's not 26, it's going to be 2 times 6. First thing I'll do, I can do PEMDAS again. Exponents. I have 3 times 6 squared is 36. Minus, I could do the multiplication over here because it's separated by the subtraction sign. 2 times 6 is 12. 36 times 3. I can't do that in my head. Let me just write it over here. 36 times 3, that's 18. That gives me 108. 108 minus 12. Well, 108 minus 8 would give me 100. 12 is 4 more, so I'll take 4 more away from 100. That gives me 96. That's an answer of 96. This right here, boys and girls, is where we struggle in class. When we have that exponent and it's times another number. Remember, substitute in, solve the exponent first, then multiply it by that coefficient. Or in this sense, coefficient, but then it's multiplied by the 6 squared, which is 36. Next one, let me erase this. Hopefully as you're doing these, you're checking your work. You have the same answer as I'm getting. Maybe you have a different answer because I'm doing it wrong. That's fine too. I have 4 times m minus 3 times n. Oh, I have two variables in this, plus 5. And it says m equals 12. I'll write down here, n equals 4. Let's substitute in 4 times m, which really means 4 times 12 now, minus 3 times n, which is 3 times 4, plus 5. 4 times 12 is 48, minus 3 times 4 is 12, plus 5. PEMDAS, I have subtraction and addition left. PEMDAS says, when I just have subtraction and addition left, I do whatever comes first from left to right. So as I move left to right, like I read a book, 48 minus 12 is 36. 36 plus 5, well, 36 plus 4 would be 40, plus 1 more is 41. 41. Okay, right. What are we writing? An algebraic expression. Remember, there's no equal signs in an expression. We're going to have a variable and a constant. We might have we'll have an operation in there. Let's take a look. The product. First word here is product. Product means to what? It means to multiply. The product of a number. Well, I can call it any variable I want because it's unknown. And 4. So we're multiplying these two. Now remember, we always put the coefficient first. I want to call it 4 times n. If you wanted to call it 4 times b, 4 times a, that is fine. Just remember to lowercase your variable. Next one, 5 less than. Less than means to subtract. But it says 5 less than a number. Now, I could write this 5 minus n, or I could write it as n minus 5. Now, looking at these two, which one is 5 less than something? 5 less than a number. So that means I have to start with the number and take 5 away from it. This starts with 5 and takes something we don't know away from it. This starts with a number and takes 5 away from it, or it's 5 less than what I started with. This would be the correct answer. This is 5 minus n, or the difference of 5 and n. This is 5 less than a number. This is the one I always see kids struggle with. The last one, 12 divided by a number. Divided by, that should really be an easy key word there, division. And I'm taking 12 and I'm dividing it, I'm breaking it into a certain number of parts, and I'll call that n. You could also write this as 12 divided by n, or you could also do this 12 divided by n. I will say this is most commonly seen this year as a fraction, because we want to think about this fractions. And fractions are just division bars. Hope this helps you out. Look for another video tomorrow. Take care.